So hi, everyone. Welcome back. Welcome to our part 2 of our Python data and scripting webinar series. So today we're going to be learning more about Python. We're going to be first learning about writing files. So last time we learned about how we would read information from a file into Python. This time we're going to be learning about how we would so we want to read information in from a file, maybe do some calculation on it, and then maybe write it back out to another file that we can use for something else. So we're going to learn how to write to files. Then we are also going to be looking at using the Python library called NumPy, and then we'll be making some graphs. So graph making is always a useful skill to have, and we'll be looking at how to do that in Python. Okay, so that's what's up for today. I will hand it over to Dr. McDonald now. She is going to show us how to write to files.
All right, welcome back, everyone. I hope you're ready for another exciting afternoon of Python learning. And you can see when I share my screen that I am on my NanoHub dashboard. So remember, if you go to nanohub.org, and you sign in, then in the upper right-hand corner, it will say that you are logged in. And if you sort of hover your mouse over that, you will be able to go to your dashboard. Okay? There are two ways that you can sort of re-access all of your Jupyter notebooks. Over here under My Tools, since we used the Jupyter Notebook last time, a lot of you will have this under your recent tools. And you can just click on it. And I'm going to actually open it in a new tab. You can just click on it and it'll bring you to this page again. If you do not have Jupyter Notebook under your My Tools on your dashboard, you can do what we did last time, which is you can come down here to Groups, and you can click on the MolSSI group, and then you can scroll down and find our class that we're having today, Python Data and Scripting. And then you can scroll down, and right here, it says we will use the Jupyter Notebook on NanoHub, and you can click on that.
Oh, Dr.
And that'll
McDonald,
take you.
Can I point something out while you're on? Can you go back to that previous page?
Yes.
So while you're on this previous page, I want to point out where the session 1 recording has been added. So here, where it used to say join Zoom meeting, it now says session 1 recording. So if you click on that, you can see the recording of session 1. Thank you, Dr. McDonald.
No worries. Okay, so again, we're on our group page here. We've clicked on the Python Data and Scripting Workshop, and it says you can use the Jupyter Notebook on NanoHub, and we're going to click there. And it's once again going to take us to this launch tool page. Okay, so again, the two ways to get here, if you go back to your dashboard, since we used the Jupyter Notebook last time, you should just be able to find it under your recent tools here and click on it, and it'll take you to the launch tool page. Or if you don't have it under My Tools, you can go to Groups. You can go to our MolSSI group. You can scroll down and click on the computational molecular science training. And then the link is right above the session recordings. We will use the Jupyter Notebook on NanoHub. So one of these two ways, you want to get to this launch tool page for the Jupyter Notebook, and you want to launch your tool. When you do this, it'll take a minute to load. And then it should bring up that same home screen that we looked at last time. And you may have not the same folders as me, and that's okay. All right. But you want to click on the MolSSI Workshop folder. And if you click on the MolSSI Workshop folder, everybody should see the data folder, which remember, we're not going to click on. We want to be in our MolSSI Workshop folder. And you should also see the file parsing notebook and the introduction notebook from last time. All right. And I want to sort of pick up with something in the file parsing notebook. So I'm going to click on the file parsing notebook to restart it. So I'm going to wait just another minute I'm going to go back to NanoHub and remind you of the 2 ways to find where we are. Again, after you log in, I always begin by going to my dashboard. If you go to the upper right-hand corner where it says logged in, it'll show you your name and you can go to your dashboard. And then again, under my tools, you should see the Jupyter Notebook because that's what we used last time. And if you click on it, it should take you to the launch tool page. Once you launch your tool, you should see your home screen again, where your MolSSI workshop folder is. And if you click on your MolSSI workshop folder, you should see your data folder, your file parsing lesson, and your introduction lesson. I am picking up something in the file parsing lesson, so I'm going to click on that, and it will reopen my notebook. And you can see here's all of my file parsing business that I did last time. Okay. Now, you may remember I said last time that when you restart your notebook, you need to rerun all of the cells. You can either do this by just hitting Shift Enter a bunch of times, like that's certainly a thing that you can do. Here I go. You can also come up here to kernel and go restart and run all. But remember, that will only run your cells until it encounters an error. So if you have that cell in the middle that had this error where I was showing you that you couldn't add 50 to energy, then you'll have to manually rerun the cells from that point forward. All right, I'm going to scroll down to the bottom of my notebook, and I'm just going to remind everybody what we were doing last time as a preview to the next thing we're going to do. So you can see that last time we had a bunch of output files, and we wanted to search every one of those files for this particular line, this final energy line, okay? So to do this, we used a double for loop. What people call the outer for loop, the first one, it opened all of our different files. So this outer for loop sort of goes through the files in that list of file names. And then the inner for loop goes through the data, the lines in one particular file, and it looks for our final energy business here. Okay? So last time, as our big finish, and I'm just going to run the cell again. Last time, as our big finish, we printed the file name and the energy from that particular file. And in this particular case, we just printed this to the screen. Like we just printed it right here, and that's all that there is. But if we were really doing this for our advisor, we probably want to be able to like email our advisor this data. And we could just cut and paste. We could, highlight it all and paste it into an email. But it's probably more useful to write this information to a new file, and then we can email our advisor that new file. Okay? Now, writing information to the file is not substantially more difficult than printing it to the screen. There's just a couple extra steps. Okay? So as you might expect, if we're going to write this information to a new file, and I don't know if you guys know what I mean by write. I just mean save all of this information to a file instead of just printing it out on the screen. So if we're going to write all this information to a file, the first thing we need to do is we need to open a file to write it to. So I'm going to come to the top of my box here, and I'm going to space down my for loop a little bit so that I have some lines at the top. And I'm going to create a new helper variable called data file. And this is one of those helper variables that helps me open a file. Okay? So the first thing I need to do is I need to give it the name of my file that I want it to open. And in this case, this is a file that I'm creating. So I could call it anything I want, but I'm going to call my file energies.txt. And then remember, previously, when we had opened a file, we had been opening it for reading, but this time we're going to open it for writing. So I'm going to put a W. And I'm not going to just put a W, I'm going to put a W plus. And the reason I'm putting this plus here is that this says that if this file doesn't exist, I want you to create it. Okay, that's what the plus part means. So if you just do W, then you would have to already have a blank file called energies.txt on your computer for this to work. And that seems annoying. So that's why we're doing the W plus instead of the W. Okay? So now writing this to a file is fundamentally not hard. You're just going to come down here and you're going to replace the print statement with data file. Remember, that's the name of my little helper variable that's holding my file open. Data file dot write. So instead of just printing this information out to the screen, it is now going to write it to the file. Okay, now I have a very important tip. This is very important. I have wasted countless hours of my life on this mistake. When you issue this data file write command, contrary to what you would think, it does not write this line of information to a file. A computer is like a person who has a really good memory, but really, really slow handwriting. So when you issue this data file write command, instead of actually writing it to the file, the computer just says, okay, I'm going to remember that you want me to write that to the file. And it doesn't actually write anything to the file until you close it. So I'm going to come down here to the bottom and I'm going to space over where I'm outside of my for loop. And the very last line I'm going to write is data file.close, open parentheses, close parentheses. And remember, it is super important that you remember to do this closing, because it won't actually write anything to the file until you close it. It'll just keep it in its memory until that moment. And there's been so many times when me or my students have been trying to write files, and we're like, where are our files? I'm telling them to write it. And it's because we forgot to do close. So don't forget to do close. Okay? So now, when I rerun this cell, it's going to be disappointing. It's going to look like nothing has happened. But remember, I'm no longer printing anything. I'm writing it to this file. Okay, so now I'm going to click back over here to my MolSSI workshop folder. And sure enough, I have this new file called energies.txt. And if I open it up, well, that actually looks pretty terrible. See how it's like smooshing it all together? Like as soon as it finishes writing this number, it immediately starts writing the next file name. Like that looks pretty terrible. Okay, so let's try again. Let's see if we can fix this and make it look less terrible. So I'm going to come back into my script. And what I probably want to do is as soon as I write one of them out, I want to go to the next line so that it'll write the next one on a new line. And all you have to do that is in your little fprint statement here, inside your quotes, just put /n. And that is what's called the new line character. And that says that I want to go to the next line in the file. Okay? So now I'm going to hit.
Sorry, Dr. McDonald. Make sure that you put the / the way Dr. McDonald has it. It has to be that slash that starts, goes towards the end.
Yeah, it moves to the right, I would say.
Yes.
Okay, it has to be that one. All right, so now when I do it again and I hit Shift Enter, it's going to rerun my cell. It's going to look like nothing has happened, but I'm going to click back over to my MolSSI workshop folder. I'm going to go down to energies.txt. I'm going to click it. And now I have this pretty nice looking file that I could send to my advisor, and they could, look at my data and see how good of a job I had done. Okay, so that is pretty much the last thing I wanted to finish up from last time. So now I believe Dr. Nash is going to go over the homework solution that she gave you that homework assignment from Tuesday.
Okay, so I'll go over how we can get this MolSSI workshop folder just because we want everyone to have it. Okay, so right now, I just clicked out on this folder here to the left. That's the root folder, or that's really like your home directory. So if you don't have your MolSSI workshop folder, and again, you only need to do this if you do not have the MolSSI workshop folder. Yes, I can zoom in. If you do not have this MolSSI workshop folder in sort of when you log into the Jupyter Notebook, so I'll show how to get it. I'm just going to click New. So what we have to do is we have to download this from the internet, and this is a way that we can download that folder. So to download that folder, I'm going to click the New button, and instead of clicking Python 3, I'm going to click Terminal. Again, if you already have the MolSSI workshop folder, you don't need to do this. But what I'm going to do is I'm going to type the words git clone, and then I'm going to paste this URL. So I am going to paste this to them. I'm going to type this command to the meeting. And you can just copy that from the chat and paste it if you need it. I'm not going to execute this because I already have the folder, so I don't need to do it at the moment. Okay, so that is how, so if you needed that, you would just press enter and then it would download the folder for you. Okay. Okay, so I am going to click on my MolSSI workshop folder, so I'm seeing my data folder. Everyone else, if you've been following along, you'll see your Jupyter notebooks here. So let's go ahead and write our homework solution. So we're going to go over what the solution was for the homework. And as a reminder, what we asked you to do for the homework was there's a file in your data folder that has the sort of, it ends in nd out. We asked you to pull certain values from that file. So I'm going to create a new notebook for this homework solution. So I'll go to New Python 3. And I'm going to have my notebook open here. The first thing I'm going to do when I get a new notebook is I'm going to write a markdown cell. And a markdown cell is for anybody who's looking at your code later. So I'm just going to write myself a note about what this cell is, or what this notebook is. And I'm just going to write homework 1, and I'll type a description, and I'll say something like my solution for homework 1. And also, we want to make sure we name the notebook to something descriptive. So I'm going to click this untitled up here and change the name, and I'll name it homework 1. And when you do these notebook names, you usually want to avoid having spaces. It's just a computer thing. Things tend to work better if you don't have spaces in the file names. Okay, so I'm going to click back over to this tab and click in the data folder and look at this file that we were going to be working with again. So this is the file that we were working with for the homework. It's an output file from a molecular dynamics simulation program. And if we scroll down, we eventually see sections that look like this. And we asked you to look for this keyword, ETOT, and we asked you to pull out the values that were associated with that keyword. So when you're programming something, when you're starting to program something to solve a problem, what usually the first thing that you want to do is sort of figure out how you would solve the problem. So one thing that I would do when I started programming is when I started thinking about a problem I wanted to solve, I would think about sort of how would I, if I were going to tell one of my friends to do this, how would I tell them to do it? And then you have to kind of figure out what the steps are. So we have to be able to figure out what each step is. We have to be able to kind of describe that. And then we have to translate that into like a language the computer can understand, which is Python. So the first thing that we have to do is figure out what we want to do. And what we want to do is pull out these values. So if I were telling someone how to do this, I would say, I want you to open this file, and then I want you to look for the word ETOT. And once you find the word ETOT, I want you to take the number that's after the equal sign. So that's how I would describe it to a person. And so again, we find this ETOT, find the equal sign, and then we find the value afterwards. And then after we kind of figure out those steps, then we have to translate it to Python. So we can go ahead and do that. So that's sort of the approach that it would take. So if you're unsure of where to start with a programming assignment, sometimes it can help to kind of write out what you want to do or kind of describe step by step what you want to do to yourself. So I'm going to go back to my notebook and start coding my solution. And one thing that you might find helpful to do is kind of write out in comments the steps that you want to take. So if we want to pull those values out of this file, the first thing we have to do is open. We have to open a file. So that's step one. If we want to get information out of the file, we have to open the file. Next, and this is something we have to do in Python, we have to read the data from the file. So we have to read the data. And then we have to look through lines and find ETOT, which I think it was ETOT. So we need to remember exactly what that was. And then we'll need to get number after equal sign. And what we want to do is we want to put all of those in a list, but we'll, and then we can say something like put number in list. So we can say something like that. So it might help you when you're starting to program to think about how you would describe it being done. But maybe you would imagine that, like, you know, your friend can't really figure out exactly how it's being done. Like you can't just say, get the numbers that go with ETOT to your friend. You have to explicitly tell them, look for an equal sign and then get the number afterwards or something like that. So you have to kind of really think about how you would explain this to someone. Okay, so this is a way you can kind of start. You can start by outlining the steps that you need to do. So now that we've outlined those steps, now we have to translate it to Python. So the first thing we have to do, open the file. We learned how to do that in the last session. When we open the file, and this is something that we'll have to remember because this is how we talk to Python. When we open the file, we have to do a few things. We have to build the file path, and then we have to use that open function. And what you'll probably be doing is probably looking at some code that you've written before that does something similar. So we have to use the open function. And then we'll remember sort of after we use the open function that we use the read lines function. So we might remember that from looking at, you know, previous code that we did. So if we want to open the file, the first thing that we're going to have to do is build that file path. And what we did last time to build the file path, which the file path is sort of you were telling your friend where to find the file, what folders you would click, like what they would click on to open the file. That's the file path. So we'll import that OS library that we need to use to build the file path. We'll do import OS. And then let's build our file path. I'll put it in a variable called file name, which you could call it, anything that you wanted, but I'm going to call my variable file name. And I'll say file name. And here I am telling the computer sort of where to look for this file, what folders to click on. I'll do OS path join, and I'm going to tell them, first, you click the data folder. Then that's the only folder they have to click. Then they click the file o3prod.md out. So that was the name of the file that we were looking at. So we open the file. So we're still working on opening the file. We've just built where that file is. So after we build that, after we build where the file is, we'll want to actually open it. So we'll make a variable called f, and we'll set that equal to open, and we'll give it that file name. And we want to open it for reading. So we are just reading the information from the file. So we'll put R here for read. I want to point out something here about color coding. So you might have noticed as you're programming that the Jupyter Notebook color codes some of your words, the words that are color coded. So for example, import, that is an important word to Python. So Python is going to make that green and bold. The word open is also a word that Python knows. That's why it's green. So it's a function that's kind of like built into the Python space, so it turns green. So it's just something to notice here. So we're going to open that file name that we built, and we're going to open it for reading. And then we remember probably from looking at code that we read that we wrote before, that the way that we actually get the data out of the file is we use a function called readlines. And if I want to save that, I'm going to have to set it equal to a variable. So make a variable called data, and I'm going to set that equal to f.readlines. And then we have to remember what Dr. McDonald said. She said that programming is like kindergarten, and if we open something, we have to close it. So now we're going to close the file with, we just type f.close. So here's the thing that we opened, and we do read lines, and then we close it. So when you're programming to solve a problem, what you might find yourself doing, an approach that I use is I have a small piece of like a small task that I want to do, like opening the file. And when you write your code, you don't have to write it all at once. You can identify those small tasks and write the code for that task and then check that it worked. So one thing that I might want to do now is I've done the first thing that I know I have to do for this problem. I have opened and read in my file. So what I would probably do at this point is check and make sure this works, because we could write the rest of it assuming that it works, but it's just easier to fix small problems as they come up instead of a lot of problems at the end. You'll find like a lot of different approaches to coding, and that's my approach. So what I would probably do here after I wrote this is I would press Shift and Enter and make sure that I didn't have any errors. I'll also take some time here to talk a little bit more about color coding in the Jupyter Notebook. So you might notice that where I have my cursor right now, these parentheses are highlighted in green. The Jupyter Notebook will match parentheses. So the reason that this is green is because those two parentheses match. So if you have like a lot of parentheses, this is a way to see which parentheses match. Another thing is that you'll notice that when a parenthesis does not have a match, it's red. So that's something that you can use to kind of troubleshoot as well. So all that we've done right now is we have opened our file, and then we've read in our data from the file into a variable called data. We executed it and we didn't see any errors, so that's a good sign. Another thing that I find useful to usually find useful to do at a point like this is to look at what's in data. So I might do something like print data just to make sure that it looks the way I think it should. And what I would expect, so we should think about what you expect here. From read lines, we expect to have a list, which last time we learned about lists, but we have a list that has an sort of an entry for each line in the file. So I can print it, and it doesn't look that pretty. So maybe actually if we do this without the print, it kind of looks better. But that looks like what I expected to me. So that's a good sign. And you could check the length or something like that. So you could just kind of check here to make sure that what is in data is what you expect. Okay, so I already kind of did this. So I think I'll move my comment up above here. And we can use kind of spacing to make things look nicer. Okay, so the next thing I want to do is I want to look through the lines and find ETOT. And so we have to think about, to write this step, we have to think about what we know about what's in this data variable. And so we know that this data variable, we could even check the type if we wanted, but we know that it's a list where every line in the file is an element in the list. So that seems like, to me, you have to kind of think about what you know about Python and what you can do. But that seems to me like probably we want to do something with a for loop. So we want to maybe look through, all the lines and find that word. So let's write a for loop for that. So we can write for line in data. So we're going to loop through each line in data. And what we want to do is we want to say for line in data. And then we want to do something if ETOT is in the line. So I think then we'd want to write an if statement. And if you were unsure of what was going to happen here, I would encourage you to write code incrementally. So you could do something like print line if you were curious about what this for loop is going to do. It's just going to print the whole file if you do that. So I'm not going to execute it. But what we'll say now is we have to think, maybe our computer is our friend that we're describing what they should do to, how to look for that. So we'll say if, and then I'll put quotes. It can be single or double quotes. Oop. If ETOT, and remember that this has to match exactly, so it needs to be an uppercase E, in line, we can do something like print. So the first thing I'm going to do is I'm just going to print the line if ETOT is in the line. And I can execute that if I want to see what it looks like. And you'll get something like this. So it's going to print out a lot of stuff. And now we kind of have to think about how we can get this number. And last time we learned a way, so this is a string. So each line is a string. And last time we learned a way that we could split a string. And the way that we did that was we used a function or a method on the string called split. So I might write something like split line, or I might say do something like split line. That's a variable. And I am going to do line dot split. And maybe now I want to print this. and think about what I should do next. So what I've done so far is I am looping over the sort of the different things in this list called data. I'm looking for the phrase ETOT, and I'm saying if there's ETOT in the line, then split the line because we need to get just this value by itself. You might have chosen to split the line, on something else. You could use an equal sign, for example, but if we do it without anything in the parentheses, then it's just going to split it on spaces. And what split means is that we get a new list. So the split splits that string, or splits that, considered as one word, into another list where each element is a word. And so if we look at this, we remember, so now we kind of have closer to what we want. We can see that we've got ETOT, an equal sign, and then the number that we want. And we'll notice that it's the same for every line. So if we think about what element of the list that is, we would count. So we would say 0, 1, 2. Okay, I need to get element number 2 because we remember that counting starts at 0 in Python. I need to get element number 2, and that's my energy in my variable split line because I had that printed. I don't want to print this all the time, so I'm going to comment it out. I figured out my rule. So now I am going to kind of do these steps. So I know I need to get the number after the equal sign and put it in a list. I need to do it inside of my for loop. I need to do it every time. I'm going to move my comments inside. I'm pressing the tab key to move them over. So first thing we need to do is get the number after the equal sign, and I'll say something like number equals split line. And remember, I figured out that that was element 2. And then I need to put the number in a list. And this is something that we learned last time. If we want to have a list, so now I might remember after I've written this code that I need to put the number in a list. So I can go back up here, up before my for loop, and I might make a list because in order to add the number to a list, we have to have the list first. So I'll make a list called energies. This is how we make an empty list. So I just went up above my for loop. I made a list called energies. And now I'm going to append this number to the list. And that was an append function. And I'm going to put number here. One thing I might remember is that I actually wanted number to be a number. And right now, when I'm looking at it, it looks like it's a word. And I can tell that Python thinks it's a word because it's put quotes around it. So if it puts quotes around it, Python usually thinks it's a word. So I'm going to recast it. And again, I just went here to the end of my comment line and pressed enter and went above where I append. And I'm just going to say number equals float number. So we learned how to do that last time. We cast this as a decimal. I feel like my comments maybe need to be arranged better. I'll just put this up here. And put in a list. So let's try executing that. And I've taken out all of my print statements, so I expect now that when I run this, if I've done it correctly, then I shouldn't see anything. So let's see. And that looks good. I don't see anything. So nothing happened. I don't have any error messages. So let me take a look at my energies list and see if it looks the way I want it to. And it does. So that's sort of how I would approach doing this problem.
Dr. Nash, in your code, could you just put your cursor on the line where you created the blank list called energies outside of the for loop? I think a couple people are missing that line.
Yes.
So yeah, right there, if I told you that you didn't create the list outside of the for loop, then that's the line that you are missing.
So for loops can be very tricky. While we're waiting, I can go over each line again. So what we wanted to do was we wanted to get the value associated with this ETOT. We wanted to get those in a list. So the first thing we did was we thought about sort of the steps that we needed to take in order to get that information out of the file. We kind of thought about those, sort of how we would describe doing that, and then we thought about how we would write code to do sort of the procedure that we thought of. So we decided when we were thinking of our procedure that the first thing we would need to do was open the file. Then after we opened the file, we would need to read data from the file. And then after we read the data from the file, we would need to look through the data or look through the lines and find the word ETOT. And then after we found the word ETOT, we wanted to take the value that was after the equal sign. That had ETOT, equal sign, and then value, and we wanted to save it in a list. So that was sort of what we thought of when we were thinking of the procedure in our head. And then we started translating it into Python. So for the first step, when we wanted to open the file, we had to import the OS library. And the OS library is what we were going to use to explain to the computer where to find the file. So we built our file path, then we opened it for reading. Then we actually read it with this. So we opened it, then we read it, and then we closed it. We didn't have this originally. We remembered later that we needed it, but that just goes to show you that sometimes when you write code, you might kind of write things out of order. Like you might write something and then realize you needed something maybe earlier in the code, so you can just go fill that in. But what we have now is we created an empty list because eventually what we want to do is to put the number in a list. And once we created our empty list, we looked through the data, we looked through the lines in the data, and then if we found the word ETOT in the line, we split it into different parts, saved the number, and then saved that number in a list. So that's what we did here. So that's what we did for the homework. Okay, so that was homework 1. Wonderful. Okay, so this is my homework 1 folder. That's like one topic. So we're going to start a new topic now. So I'm going to go back out and I'm going to start a new notebook. When I start my new notebook, you might be in your data folder if you were looking at the file with me. But I want everyone to make sure that you are in your MolSSI workshop folder. So we're in our MolSSI workshop folder. We see our notebooks here, and then we see the data folder. We see the data folder here as well. So the next topic that we're going to cover is we're going to talk about something that we call tabular data, or this is data that is in a table. So it's data that has rows and columns, and it's maybe the kind of data you're used to looking at in Excel. So we're going to be using the library called NumPy to work with and analyze data that is tabular or data that has rows and columns. So when we're working in Python, so far we've learned one way to read information from files. But when we're working in Python, there are actually a lot of different ways to read information from files. And depending on the type of data that you have, you might want to read information from files in different ways. So I just opened a new notebook, and I forgot to explicitly say what I did. So I'm just going back out here. I want everyone to create a new notebook. So click on New, and then Python 3 to open a new notebook. And this is going to be the notebook for our NumPy lesson. So after you open that new Python 3 notebook, you'll be in a new Jupyter notebook. We're going to rename it. First thing, I'll call it NumPy lesson. So you can do a dash if you want, or you can do an underscore here, but it's just good to not have spaces in your file names. So I just named my notebook NumPy lesson, and then I'm going to write a note to myself about what this lesson is. So I'm going to change to a markdown cell. Again, the markdown cell is for me or for anyone else looking at this. It's not for the computer. So we're just going to type it so that we know what we're doing. So I'm going to type, I did the hashtag to make the title, and I'll type NumPy lesson, and then I can type a description. I can type the date if I want. Just something for people who are looking at it later. And I pressed Shift Enter to execute that. So we're in our NumPy lesson. We're going to show how to use NumPy. And if you don't have exactly what I have here, that's okay. This isn't code. It's just a note. So you can write anything that you want. Okay, so I said this a few minutes ago, but in Python, there are, if we want to read data from files, there are multiple ways that we can do that. So we learned one way to do it, and that is if we want to get information from a file, we can open it, we can use read lines, and then we can loop through the file. That works really well if you have something that has, you know, if it's something like has a lot of words in it, or it's not exactly like a table. But if you have data that looks like a table, there are other ways that may be easier to read the data in. So I'm going to click back here to my file navigation window, and I'm going to show you the data file that we're going to be working with for this lesson. You do not have to open it. You don't have to look at it if you don't want to. I'm going to show it to you. But the file that we're going to be working with is called distance data headers and then .csv. And so this .csv, that stands for comma separated value. And if you see a file that says .csv, that's usually going to mean that it's a file that you could maybe read in using Excel or something. So it usually is a file that is what we would call tabular, or it has rows and columns. So I clicked on that file. On the top here, you're going to see that I have something that looks like headers. So I have the word frame, and then for those of you who have taken biochemistry, these are amino acids, and then ATP. So this is data from a molecular dynamics simulation, again, where we've measured the distance between different amino acids and, say, ATP. And that's what this top part says. So that's labeling each column, and then we have the data in the rest of it. You'll notice that each value here is separated using a comma. So we have frame, comma, next value. So it's value, comma, next value. And that's why it's called a comma separated value file. And so when you are reading in comma separated value files into Python, you can kind of think of using the previous method that we learned. The way that you might work with this is you might open it, use read lines, and then maybe split on the commas. But because this file has rows and columns, and particularly because every row has the same number of values, there are other functions that we can use to read this in, and we're going to use one in NumPy. Okay, so I've said this is our NumPy lesson, so I'm going to click back over to my Jupyter Notebook. So since we are going to use NumPy, the first thing that we're going to use NumPy is we are going to import it. So what I'm going to do is I'm going to use NumPy to read in data from that file I just showed you. So the first thing I'm going to do is import NumPy. And we're going to be using a particular function in NumPy, and this is a function that Dr. McDonald and I know about, so we're going to use If you didn't know about this function, the way you might find it is by actually just Googling it. But we're going to be using a function called NumPy gen from txt. And I'm going to show you sort of a tool that we can use in Python to get more information about the functions that we're going to use. So Python has a built-in function called help. And you can tell that it's built in and Python knows this word is important because it's green. So if you ever need help, if you need to know something about a function and you know the function name, you can use this help function to get information about that. You can use help to get information about that function. So I said we're going to use a function called NumPy gen from txt. So this is how you spell it. And I just want to read the help on this. So I've just typed help and then numpy.gen from txt. And I'm going to execute that and look at what the help is. Okay, so this is my help. It's going to tell me how to use the function. So how I would read this is I see gen from txt, that's the function name. Then it tells you what you can put in parentheses when you use the function. And we see that it says fname, so that is file name. And then there are a lot of other options here that you can use. So for example, we can tell it a delimiter, which is sort of what the values are separated by. It also has these very interesting arguments here called the skip header and skip footer, which you might find useful at some point. But this allows you to skip a certain number of lines, say in the file you're reading, like maybe if it has some comments at the beginning. Same for skip footer. And then just a lot of options here. So you can kind of scroll down. If we look farther down on the help, we're going to see sort of a detailed description of every parameter or everything that we can put into this function. So the first one says fname, and it says file name to read. So the first thing we give this function is the file name, and then it tells us about the other ones. So we can see that another thing that we can give the function is dtype, which is data type, and that's optional, but we can just read about the function that we want to use here. And if if you need some help on the function, this might be a good place to look. The thing that I think is important for reading the file that I showed you is this file name. We definitely need that. We need that every time we use the function because it's not optional. But I also think that this argument is going to be important. That says delimiter. And I would know that from reading. So if I read here, it says the string used to separate values. So we were using a comma separated value file. So I think that we probably want to use a comma as our delimiter here to separate the values. The other thing that's going to be important for us for the example that we're doing is we are going to want to specify the data type. So when we're working, this is going to read our data into something called a NumPy array. And when we're working with a NumPy array, everything in the NumPy array has to have the same data type. We've got a mixture of words and numbers in that file that we're going to read. So we're going to specify our data type as well, and we're going to specify something called Unicode. So let's go ahead and build that file, or let's go ahead and use this function now that we've read all about it. So the first thing we want to do is we will actually want to import OS because we always have to build our file paths. So I'm going to import OS. And then I'm going to build my file path. And I want to maybe insert a cell. I'm trying to move this up a little bit. So I'm going to import OS, and then I'm going to build my file path. We're going to use that function we know called OSPathJoin, our favorite function, to tell the computer where to look for this file. So we're going to say, okay, computer, if we want to read this file in, we're going to click on the data folder. And then after you click on the data folder, you're going to look for a file called distance data headers.csv. And I know that because I've looked at what the file is called. So I've built that file path. Now I want to use my NumPy gen from txt function. And I'm going to use those options that we figured out from reading the help. So I'm going to create a variable called distances. I'm going to set it equal to NumPy, and then I'm going to use that function gen from txt. I'm going to give it the distance file as the file name. Then remember, this is a comma-separated value file, so I'm going to tell it my delimiter. And I'm going to tell it my delimiter is a comma. And then I am going to tell it my data type, and we're going to tell it data type Unicode because we have a mixture of words and numbers. So if we didn't specify this, it would read in everything as a number. But we would lose all of our information on the headers. So we want to keep that information about the headers, so we're using D-type Unicode. If we had something that didn't have headers, maybe we wouldn't want to specify what the data type was. And then after I use my function, I'm going to print distances just to make sure that I read in my data. And I will execute that. And if we typed everything correctly, then we should see something that like this, that's output. Sort of while we're waiting for people to get this code, I'll kind of talk about what we have in this distances variable. So you'll notice that this NumPy gen from txt did a lot of work for us. So what we have printed out here, it looks like a list, right? So what we have is we have frame, and this is a list. So this looks like a list of lists. That's what it looks like. Well, we have frame, this first one that has the headers, frame, THR4 ATP. Then we have another that has these values in it, and then so on. These three dots, it's something that's like ... to indicate that they are hiding a lot of stuff from you. So the way that this prints out, it's going to print the first three rows, then it's going to put ... and then it shows you the last three rows. But really, we have 10,000 rows here. So you can tell these, this first column just counts those numbers. But if we think about what this did, it actually did a lot of work for us that if we had used read lines that we would have had to kind of do ourselves. So if we used read lines, we still would have had to build the file path, but then we would have had to open the function. Then we would have had to use read lines to read the data. Then we would have had to close the file. Then we would have had to have a for loop that's split on commas. And we would have had to append that to a list. So this gen from txt function did a lot of work for us, but it was only able to do that because this data has rows and columns. So there are the same number of columns in every row. We had a good question in the chat. It says there are no commas. Is this a different type of list? And the answer is yes, it is. So it looks like a list, but it's actually a NumPy array. So one thing that you might ask yourself is, you might say, what exactly is this? And then you could call type on it. So we could do type distances. And instead of list, we're going to see NumPy.nd array. So this is not a list. It looks like one. And we're going to see that in a lot of ways, you can do a lot of the same things that you can do with lists with NumPy arrays, but they also have some special capabilities. So that's the special thing about using NumPy. So if you hear anyone talk about Python and NumPy, the very special thing about NumPy is that it has this NumPy array, and there are a lot of, say, mathematical operations built in on this NumPy array that we can do. but it does look like a list, but it doesn't have the commas, and that is because it is a NumPy array. Okay, so we've got our NumPy array. So let's talk about how we would actually work with our NumPy array. So I said that it looks like a list of lists. Just like a list, we can slice a NumPy array. So I can say something. So I'm going to put some comments in here and say something like distances is a NumPy array. So that's just a comment to myself. And then I'm going to put a comment that says something like, we can slice a NumPy array. So for example, if I want to pull out just these headers, I see that looks like the first element of this list. So I can do something like headers equals distances 0. And then I'm going to print my headers. So I've made an error here. So I just executed this code, and I'm getting an error message. It says for me, name error, name distances is not defined. When you get an error like this, again, reading an error message, we read the bottom first because Python will tell us sort of what the error is at the bottom. And then if we look up, here, it's got an arrow to the line where I made my error. So I've made an error here. It's on line 2. I can tell because this arrow points to that line. And so now I know that my problem is on this line. And it's also, I can see that it says this is not defined. So that means it doesn't recognize that as a variable. So I'm going to check my spelling, and I'm going to see that I missed a T. So I made a typo here. So I'll fix that. And now I have my headers as a slice. So I have an exercise for you. What I want you to do is take a slice of the NumPy array that is only the numbers. So I just took out this first line, that's the headers. And now I want you to slice this NumPy array so that you get just the numbers. So everything that is not the headers. So I want you to take this distances variable and take a slice of the NumPy array that's only the numbers. You might have to think back to some slicing. Yes, all of the numbers except the headers, everything that is not the first line. So yes, all of the numbers. So what I have highlighted. Oh, okay. One person wants to hit, that's all I need. Okay, so we need to take a slice that is only the numbers, which is everything but the headers. So if we think about what that means is we want to take a slice that goes from the second row or row index 1 to the end. And there was a way during session 1 where we learned how to take like a range of, so if we wanted like 0 to 3, we would put 0 something 3. Or if we wanted from an index to the end, we would put the index number and then a certain character to the end. Then nothing, just that character. And that character rhymes with Schmollen, if that helps. Schmollen is not a word, no. This is something we did. Okay, so let's talk about that. So what we did here is we wanted to take a slice of the NumPy array that's only numbers. So this is the first one. So when I said only numbers, I mean everything but the headers. Headers was 0. So we want everything from 1 to the end. So if we want the numbers, we want everything from 1 to the end. So I'm going to create a variable called data. And then I'm going to take my slice that is just the numbers. So I'm going to do distances. And then I want to start at 1. And then that character, so I'm saying start at 1, and then I want to go until the end. And that character that we used for that was a colon. So remember from the first session when we wanted to do a slice, and I'll type a little note to myself to do a slice, we can do list, start, colon, stop. So this is something that we went over last time. So if we want more than one element of a list, we use this sort of syntax. So if we want to start at row index 1 and go to the end, we don't have to put anything after the colon. So we just do 1 colon and then close this. So these are distances, square brackets, 1 colon, and that's going to give us everything until the end. So I'm going to print data. And there it is. So we can't see this because it's showing us our ... So that's like just telling us there are a lot of rows here. It's not showing us. But if we wanted to know how many rows there were, we could do length. So can do get the length. So that's 10,000. So we had a question in the chat about how it formats things differently. So if you just do data without print and it's the last thing in your cell, you might see something that looks like this, and it does have commas in it. It also has this word array. So depending on what you do, you might see something slightly different. And this is just like a funky thing about the way Python works. So that's just kind of unfortunate, but it is just a little like, just sometimes what you see if you print versus what you see this way is different. So it just depends on sort of the people who wrote the code because they decided how it was going to be formatted. Okay, so we have our data. But one thing I'll point out to you about this data, whether it is printed this way or this way, is that I have quotes around my numbers. So what does that usually tell us? What it usually tells us, what that usually indicates to me, yes, exactly, is that Python thinks that this is a word. And it thinks it's a word because we use that D-type Unicode. So now we need to tell the computer, and we can even see this here. It's hard to tell, but that means that it's a word. We need to tell the computer that these are numbers. So we're going to use a slightly different way to do this because this is a NumPy array. So we're going to say data equals data, and then AS type. So we're saying it assign the type, and we'll use something called NumPy float. So this is how we tell the computer make data into numbers. Uh-oh. Oh, looks like this is don't worry, it's just a warning. It means Dr. McDonald and I need to update the lessons a little bit, but it still is working right now. But this has made data into a float, which we remember a float is a decimal number. Okay, so what we have so far is we've got this data. I mentioned before it was some data from some molecular dynamics simulation. And when we have data, what we probably want to do is do some analysis on this data. So maybe what we're interested in for this data is like what the average is, for example, like what the average of the columns are. Oh, before we go over that, I want to go over one more thing about accessing. Before we get to analyzing this, I want to go over one more thing about accessing data in this variable or in the data frame, and not data frame, in the NumPy array. So here it's something, it looks like a list of lists. I said it's two-dimensional, so it has rows and columns. So now we can use two numbers to describe where the data is or what data we want. So say, for example, we just want to pull out this value 8.9542. We know that that is in, if we look at data, that is in the first row and the second column. So we can use two numbers to describe where data is in our array. So when we are slicing, we can use two numbers to slice a NumPy array. And when we do that, we're going to put the array name and then square brackets, and then we're going to put the row number and then the column number that we want. Remember that when we do these row numbers and column numbers, counting starts at 0. So this is how we use two numbers to slice a NumPy array. We give the array name, then a bracket, then the row number, and the column number. And this is different than a Python list, because when we work with a Python list, we can only ever use one number. But with a NumPy array, we can use two. So I used this as an example already, but let's say we wanted to get this value. So I'm going to say I want to get that value. I'm going to say this is in the first row, but we remember that counting starts at 0 in Python. So we'll do row 0, and then column 0, column 1. So that's how I think I would find that. I would say row 0, column 1, and then I get that value. So here is a little quiz for you. Oop. So go ahead and take a minute and think about what you think the output of this code will be. So you can type it, don't execute it, try to predict what you think the answer will be before you run the cell. And when you think you have it, execute it and see if you got the right answer. Okay, now I'm going to kind of think about what I think the answer is going to be here. So for the first one, I see the first number is 1, so that is the row number. So I'll remember that counting starts at 0, so I'll go 0, 1. So here is the row I expect to be in. Then the second number is 0, so I expect this first answer to be 2. So I think that my first print statement is going to be 2. Then the next one, I've got 2, 2. So I'll go here, I'll go 0, 1, 2. So I think it's on this row. And then I'll count 0, 1, 2. So I think that's going to print 6.0637. So now that I have an idea of what I think that's going to be, I can execute it and check myself. And I'm happy because that's what I thought it was going to be. Okay. So with this slicing in rows and columns, you can also use that colon that we talked about before. So if we want to get multiple rows or multiple columns, we can use the colon to do that. So I'm going to create a variable called small data. I'm going to make it have just the first 10 rows and just the first 3 columns. So remember, so we'll do small data, and I'm going to slice it to have just the first 10 rows. So I can be super explicit with this if I want. I can start at 0, then do a colon and go to row 10. And remember that when we type this 10 here, it's going to go up to, but not including the row number 10 when we're counting from 0. That's still going to give us 10 rows because it's going to be 0, 1, 2, 3, up to 9. That's 10 rows. And then we want the first 3 columns. So I'll do 0:3. And then I'm going to print small data. And now I have a small array that has just the first 10 rows and just the first 3 columns. So that is how you can analyze, or that's how you can sort of slice NumPy arrays. We can do single numbers, always row, column, but we can also use that colon to get a range of rows or multiple columns. So I have one more thinking exercise for you, and then we'll take a break. So think of, if I type this, let's try and see if you can predict what will be printed here. And printed here. And you have to think about what it meant, what we said it means, what it could mean if we don't have any numbers on the colon. So we're back from our break. So your assignment before the break was to kind of think about what we would get from printing this. And this used sort of that colon that we can use to get multiple values, multiple rows or columns. So we're going to think about what comes out if we have these. The first one was small data, and then we have a 5 here, and then a colon. And a colon without numbers on either side just means everything. So here we're saying row number 5, column, all the columns. That's what we're saying. So if we do row 5, we're going to have to start counting at 0. So we'll do 0, 1, 2, 3, 4, 5. So, and then we want all of the columns. So this is what we would expect to print out of that first print statement. And it's row 5, but it has a 6 here, and that's because counting starts at 0 in Python. So counted 0, 1, 2, 3, 4, 5. So we're getting this row. The next one, we have a colon where the rows are. So that means we're going to get all the rows. And then we've said for the column, we want to start at 1 and go to the end. So if we get all the rows and then column 1 to the end, then I would expect these 2 columns. So these 2 columns at the end to be my answer. So I can execute that, see if I'm correct. So here's my first print statement. I've got just that row with 6. And then here's my second print statement, and it's just the last 2 columns. So that is sort of how we can slice, reminder of how we can slice arrays with this colon. Okay, so, but that's all great. So that's how we can access data in an NumPy array. But one really great thing about NumPy and NumPy arrays is that there is lots of analysis built in that we can do. So NumPy has a lot of analysis functions. So for example, one thing I can do is I can calculate the mean or the average of my data. And I'm going to write a comment here to show myself how I would do that. So I could do something like data average equals, and then I would put my function numpy.mean. So this is a function that NumPy has, and then I'll put parentheses, and then in the parentheses I put data to take mean of, like whatever that variable is, whatever the data is, I put it in parentheses to take the mean. So I have a cat, and he just walked in and started meowing, so I might have to put him out of the room if he makes too much noise, but if you hear something, that's what that is. So I'll do numpy.mean, and then the data I want to take the average of. And that's how I would use the numpy.mean function. So let's take, so I said that one thing that we might want to do is take the average of each column. So our data had headers, and then it had, for the headers, some of those were, say, threonine 4 ATP. So these are distances between amino acids. So maybe I want to take the mean of just the first column. So I'm going to create a variable of just the first column. And by first, well, really the second column. So I'm going to skip this one that's just counting. I'm going to create a variable called THR4 ATP. And this just matches my header name. And I'm going to take a slice and I'm going to say, give me all the rows, just column index 1. And if I wanted, I could print that. And that's just going to show me those values. It's printing it sort of this way for me to save space, but it's showing me the first 3, then giving 3 dots, and then showing the last 3. So let's say I want to take the average of the values in this column. I can use this comment I wrote, the same kind of like syntax in the comment I wrote. I can say, I can create a variable called AVG. So I'm just naming the variable so that I know what is in the variable, but you could call the variable anything you want. And I'm going to do numpy.mean, and then I'm going to put this slice that I took, this column, in that mean function. So I'll do THR4 underscore ATP. And then I can print that average that I calculated. And it is 10.87695, a lot of numbers. So that is the mean that NumPy has calculated for that column. Okay, so we printed this average. So with this file that we're analyzing, with this data, what we probably want to do is we want to calculate the average for every column, right? So instead of calculating, like what we could do is we could slice each column and then take the average and call numpy.mean. But another way that we might think to do it based on what we've learned so far is that also sounds like a for loop to me, because we want to do it on every column. But we're going to learn a different kind of for loop than what we used before. So this time, if I think about what I would do if I wanted to take the mean for each row, is if I wanted to take the mean for the next, not for each row, for each column. If I wanted to take the mean for the next column, what I could do is I could change this number to 2. And then I could call mean again, and that would give me the average for the next column. Then if I wanted the next column, I could change it to 3. And then I could keep doing that until I got through all of the columns. So this time what I want to do in my for loop is I want to count. I want to count over a number. So I want it to go 1, 2, 3. So if we want to have a for loop that counts in Python, then we write it a little bit differently than what we've written before. So what we want to do is we want to count. We want to count over the number of rows. So where we would stop with this number is our final row index. So not row, our final column index. Sorry, it's getting late, my brain. So we want to start for this number with our final column index. So what we need then is we need the number of columns. So this is an exercise. Write some code to figure out the number of columns in data. So I'm going to write something equals, and so I want you to write your code here. So you might have to think of some functions that we used, maybe something we used last time. Here's a hint. There are multiple ways to do this, but one way you might think of might involve using your headers variable. Okay, so if I were thinking about how to figure out the number of columns, I might look at this headers variable and I would think, well, the number of columns is equal to the number of things or the number of elements in this headers kind of list. So I could count that myself, 1, 2, 3, 4, 5. But I want to have a way to like tell the computer what it is, and so that it will also work if I change, say, the file that I'm reading in. But what I want to figure out is how many things are in this headers list. And what I might remember is I know a way to do that. I learned that during the first session. I know that if I want the number of headers in a list, or not the number of headers, the number of things in a list, I can use the length function, len. And then I put in the parentheses the thing that I want the length of. So I want the length of headers, and that's going to tell me how many columns I have, because how many columns I have is, or how many things I have in my headers list is how many columns I have. So I can maybe print that. Okay, so now we'll go back to that thing I mentioned before, which was what I have to keep our end goal in sight. What I want to do is I want to find the average of each column. So I said that if I wanted to do that, first I would change it to 1, then I would change it to 2, then I would change it to 3, and then I could calculate my mean. But I want to get the computer to do that for me. I don't want to have to change that number myself. So if we have something where we want to change a number, if we want to change a number in Python, we do something called a range for loop. And it looks a lot like the for loops we had before. So we'll say something like for I, and usually when people use a range for loop, they'll just use one letter here for the thing that is going to be in the for loop. And they'll say for I in, and then we'll say range, and then we will say something like num columns. And I just want to show you the way that this works. So I've made my for loop here. I put my colon, and then I press enter. And since I put my colon, it's going to indent for me, so it's indented. And then I'm going to print I. So I'm just showing you the way the for loop works. So when I do a for loop using range, it's going to make a variable that counts. So first I will be 0, then I will be 1, then I will be 2, then I will be 3, then I will be 4. So we put num columns here. Num columns was 5. But remember, in Python, a lot of times we go up to, but not including the number that we put. So we go up to 4. So we count to 4 when we put 5 inside of the range function. So now I want to use this to count, to basically change this number. I want to use that I instead of the number. So I can do something like, I can say column equals, and then I'm going to take a slice. I'll say data, and then I'll say I want all of the rows, and then the column number is going to be I. Because remember, I is going to be 0, then 1, then 2, then 3, then 4. So we're getting the computer to change this number for us. So we're getting Python to change that number for us instead of us having to go in and change it. And this is a file that only has 5 columns, so you could probably do it yourself. But if you're working with a file that has hundreds or thousands of columns, you definitely don't want to be changing that yourself. So this for loop is much better for that. So notice the similarity here. So this looks really similar. We've just changed that number with the letter I, and the I is counting. So then I'm going to put the rest of my code for calculating an average, and I'll do average column. I'm going to create a variable called avgcol, and then I'll call my numpy.mean function, and then I'll put in the column, and then I probably want to print what I did. So I'll just print, and then I'm going to print my average. So let's execute that. And then we'll get the average for each column. So you can probably think of some ways that we could make this average that we've printed a little bit better. So one thing is that I don't exactly know what goes, like one way I might make this better is kind of by including the headers, right? So I have a little bit of a label to my data. So let's think about how we could include the headers. So I'm going to go up here to my for loop. I'm going to be here at the end of my line that says column colon comma I. And then I want to get the header that sort of goes with the data that I got. And we can use that using this I also. So when we're doing I, when we're getting the first, when we have 0, we're also getting 0 in the header. So that corresponds to this, this label. Same thing. So we can use the I to also count over the headers. So I'm going to create a variable called call header, set that equal to headers I. And then in my print statement, I'm just going to do an average, and then I'm just going to do a comma first, and then I'll make it better. I can do call header and then average. And that looks a little better. But if we want to be even fancier, we can use that F string printing Dr. McDonald taught us. And I'm going to put a big capital F, and then I'm going to put quotes, and I'll just put quotes around what I have. But remember that when we put these in quotes with the F, we have to have these curly braces around our variables. And then maybe I want a colon here instead of a comma. So now I've got the average for each column of my data, and I've got it printed really nicely with my headers.
Dr. Nash.
Yes.
If this is Dr. McDonald, if you only wanted to print a few decimal places, like, do we really need all of those decimal places on the average? Could I change it to only print a few decimal places?
Yes, Dr. McDonald, you can. That's a really great question. So let's say we look at this and we're like, that's a lot of sig figs. I'm not sure that we actually know it with that precision. We can use our big F string printing to kind of limit the number of decimal places that we're printing. And the way that we do that, so let's say here I only want to print 10.876. I can use my F string printing for that, and this is an advantage of doing F string printing. I come here in my curly braces and at the end of my variable name, and then I put a colon because Python loves colons, and then I'll put a dot for a decimal place. So I'm saying print 3 decimal places, print 3 numbers after the decimal place, and then we put an F. Actually, I think we might not need the F. No, we do need the F. So if we want to print just 3 numbers after the decimal place, we could put we could go to the end of our variable name. We put a colon, then a dot 3F to tell it we want just 3 numbers after the decimal. And there are a lot of different things that you can do in F-string printing. So we could do even more fancy things, but if we just want to do the decimals, this is how we do that. And you'll notice that it also, you may or may not notice this, I think it rounded this up. I would look, but I don't want it to be confusing. So there, that looks very nice. And you can also imagine how we can use the skills that we learned from writing files to maybe write this to a file that we could use later. So that is an introduction to NumPy and some analysis with NumPy. So what we did, so I want to go over what we learned in this lesson before we move on to the next one, which our final lesson for tonight is plotting. So I'm going to go over what all we've done so far in here, this notebook. Okay, so here is the top of the notebook. It's our lesson on how to use NumPy, or it shows some of how to use NumPy. There's actually like so much more in NumPy. It's a really great library. There's a lot that you can do with it. We've kind of scratched the surface. But the first thing that we did was we imported NumPy because we wanted to use it. And what we wanted, when we started this notebook, what we thought we wanted to do was use NumPy to read data from a comma-separated value file. The comma-separated value file has data that's basically in a table, so it has rows and columns. And this is something Dr. McDonald and I told you, but we told you that when we have some data like that, we want to use a function, or one function we might want to use is NumPy gen from txt. And if you didn't know that, if Dr. McDonald and I didn't tell you that, one way you might find it out is by using Google. So programmers use Google all the time. So I called help on NumPy gen from txt. It gave me some help on the function. Here's the function name. And then underneath, it gave us some parameters. We kind of looked at the different parameters. We figured out we needed to specify the file name, the data type, and the delimiter. So we read this, and when we figured out that's what we needed to use, then we imported OS so we could build our file path. We built our file path, and we opened the file. And then we printed distances to make sure that we sort of had what we wanted. We noticed that this looks a little bit different than what we usually see, so we checked the type. We saw that since we use the NumPy function, we have our data in something called a NumPy array. Then we sliced the headers, and then we sliced the data. So here we used our colon to go to the end. We printed our data, and then we printed the number of rows. We have 10,000 rows. Then we changed it from a word into a number, so we cast it as a float. Then we learned about slicing with row numbers and column numbers. We made a small data using our colon with rows and columns. And then finally, we learned how to calculate the mean of each column. So that's what we did here with this range for loop. So this for loop, it was a new kind of for loop, and it's the kind that we use when we want to count. So we noticed when we thought about what we wanted to do here, we noticed that we were changing a number. And when we change a number, we can use a for loop called a range. So that's what we did. This range makes I into a number that counts up to whatever number you have here. So that's what we did with NumPy. So we're going to be staying in the same notebook. We are going to be, we're going to stay in the same notebook. We're going to be learning now about plotting. Since this is a new section, I'm going to change this next cell to Markdown. I'm going to call it plotting. And we're going to stay in the same notebook because we're going to be using the same data. So I'll write a comment to myself. So my comment, it says, this part will show how to plot using the Python library matplotlib. So we're going to be plotting using a Python library called matplotlib. If you program more in Python, you may see other plotting libraries that people use. Matplotlib is perhaps one of the oldest Python plotting libraries. It's been around since about 2003. So it's been around for a while. But it's very commonly used, and so if you learn Matplotlib, you'll recognize a lot of plotting. There are other libraries out there these days. So in order to use Matplotlib, we have to import it. So just like any library that we're using, OS is a library we have to import, NumPy is a library we have to import, and Matplotlib is a library that we have to import. So when we import Matplotlib, it's a little bit different than sort of what you've seen before, but we're going to do import and then matplotlib.pyplot. So this is the import that we do. So we're going to learn a cool Python trick here, because if we think about when we do this import, what we usually do when we import something is we say, if we say import NumPy, then every time we call a NumPy function, we have to write the word NumPy and then put a dot and then the function name. We think about what we would do with matplotlib. We would type matplotlib.pyplot, then the function, and that's like a lot to type. So what Python actually lets you do is it lets you give these imports nicknames. So if we want to change sort of what we type when we use a matplotlib function, we can say import matplotlib.pyplot, and then we can put the word as, and then we put what we want to call it instead. You could call this anything, like you could call it anything you wanted, but just what people usually do. So you'll notice that when people use these as statements, if people are using the same libraries, they usually all call it the same thing, but they'll usually call it PLT. So usually we'll import matplotlib.pyplot as PLT. But if you really wanted to, you could use something different. So that's just going to make it so that every time we use a function from matplotlib, we don't have to type matplotlib.pyplot. Instead, we can just type PLT. Okay, and we can execute that, and it will import the library for us. It's taking a little bit of time. Okay, there we go. So it should execute, and that means that now we have PLT, and we can use matplotlib functions. So if we want to plot a figure, what we do first is we can create a figure by saying plt.figure. That is going to, so let's say we want to plot the first column of data. That's what we're going to go with. And by column index 1, not like the very first one, because that's just the frames. But let's say we actually want to plot our data. We can do plt.figure. That's going to create a new plot. And then to create a plot, we do plt.plot, and then in parentheses, we put what we want to plot. So I said I wanted to plot column index 1. I want to skip sort of that first column. So remember, our first column is just the frame number that just counts up 1, 2, 3, 4, 5. So I'm going to skip that, and I'm going to plot data, all the rows, column index 1. And that's going to make a nice plot for me. So you can see this is what a graph of our data looks like. So I think that this is really great. So I kind of can see more about what's going on with my data here. So remember, I said this was a distance. So I can see that here the distance goes up, and then here it goes down. And so that gives me a really nice visualization of what my distances look like. However, if you were going to use this, so most of the time when we're making plots, we're making them to show to other people. We might want to put this in a lab report, or we might want to put this on a poster. If you do research, you might want to put it on a poster. And if we're going to present it somewhere like that, we probably want some more information on this plot. Like maybe we want to label what the x-axis is, or what the y-axis is, or what this data is. So let's take some time and kind of improve this figure to make it into something that we can actually use. So I am going to come here. Actually, I'll just go down to the next one. I'm going to say create a better plot. And I'll do plt.figure to make a plot again. And then this time, let's say I want to, I'm going to plot the same data, but I want to add some more information about it. I'll do plt. Before I add my data, I'm going to add a label to my x-axis. So to add a label to my x-axis, I just type plt.xlabel. And then in parentheses, I put what I want the label to be. And I'm going to put simulation frame. And then I probably want to plot, or I probably want to add a label to the y-axis. So I'll do plt.ylabel, and I'll say distance. And then maybe I want to say it's in angstrom. So that's going to be my y label. So my x label is simulation frame. My y label is distance. You can label those with plt.xlabel and plt.ylabel. And then I'm going to plot my data again. So I'll do plt.plot. I'll put that same data in, colon 1, colon, comma 1. And let me just take a look at that. Okay. So when I do that, I'm going to see that I have my y label and my x label. And I think one other way I can make this better is maybe I can put the data name, like the header name, in a legend or something like that. So that's what I'm going to do. So if I want to label my data, I can put comma after this data that I wanted to plot, and then I type the word label, and then I can type what I want my label to be. You could type something here, like in a string, or you can use a variable. We're going to use that headers variable again, and I'm going to use 1 here. So here I'm using 1 to get my column, and then I'm using 1 to get my header. And this will make us have a legend, but we have to tell matplotlib we want it to show us the legend. So I'll do plt.legend, open and close parentheses. And now I'm going to have a legend here with this label. So I think this looks pretty nice. I have my data now, it's all labeled. I've got my x-axis labeled, I've got my y-axis labeled, and I can tell what the data is because I've added this legend. So, now I think this is probably ready to go. Like, I can save this, I can put it in my lab report, or I can put it on my poster or something. I think that this looks good. So what I want to do now is I want to save the figure. You might think of doing something like taking a screenshot, but there's a better way. Matplotlib has a function that we can use to save our figures. And what we're going to do is we're going to use that function, and it is plt.savefig with a G. And then in parentheses, we put the name of the file. So I might say something like myplot.png. So if we do .png, it's going to be a PNG image. So if we want to save our picture, we do plt.savefig, and then in parentheses, you put in quotes the name of the file that you want to save it as. So I'm going to execute that. And then after I've executed that, I'm going to pop out here to my MolSSI workshop folder. So I'm in my data folder. I'm going to click in the same directory as my Jupyter notebook. And now I'm going to see this file here called myplot.png. And I can open that and I can see my plot. So if I was using NanoHub, I could download this, and then I could email it or put in my lab report or put it on my poster. So here's the plot. There's one thing that you might notice about this plot, though, particularly if you want to use it for a poster, and that is that, this doesn't look very good. The quality is not very high here, so it's kind of grainy. So if you're going to use this plot for, a poster, you might be interested in making it higher quality. So the way that we can do that is here. We want to make this sort of higher definition. We can come in here and add a comma and then add an argument called DPI. This stands for dots per inch. And then we can set that to something. The default is something like 70. We can set it to something like 300 to just make our image higher quality. So if you're doing something like a poster, you'll definitely want to do this. I'm going to save it as a different file. Maybe I'll just put HQ for high quality so you can see the difference. But here I've increased the image resolution or the image quality by adding this argument DPI equals, and then you can set it to something. The higher the number it is, sort of the better quality the image is, but it will take longer to write and it will be a bigger file. So that's the downside. So you probably couldn't tell, but that took a lot longer than the previous one. So let's look at that one though, so you can see that that's appeared. And this one looks much better. So if we zoom in, it looks much better than the other one. So this is just creating a plot with matplotlib. We looked at adding labels, and then we looked at how we can save the figure. So this might be ready to go, something that we can use. Okay, but when you're making your plots, you might want more than one, say more than one thing on the same plot. So let's talk about how to do that. So I'm going to leave this here just to remind myself how to do it, but I'm going to copy it and I'm going to go down to the next cell. I'm going to write a note to myself about what this is. I'm going to say, I want to this time create a plot with multiple lines. Okay, so if I want to create a plot with more than one line, so let's say I want to do the next one, I can just add another plot statement. So if I want to do the next column, I'll do plt.plot, and then I'll do data : 2, and then label equals headers 2. So if I want to put more plots on the same figure, I just add more plot statements. And I can execute that. Oh no, I wrote over my other one. So that's something you'll have to be careful of if you're copying and pasting code. I forgot to give my file a different name. So I wrote over the one that I made originally. So I'm going to change this to 1. HQ actually. I'll run this again, and then I'm going to make sure to change my file name here. And these file names can get, I usually try to make my file names descriptive of what's in the plot, so I'll execute that again. And now I've got both of my both pieces of data on this, or both columns on the same plot. So you can kind of use this to visually examine. I think that I said when I was looking at this, I was like, oh, the distance goes up and then it goes down. This one is like pretty even. So that's kind of interesting. But let's say that I want to create a plot with all of my columns. Can anyone think of how I would do that? So if I think about the way I would do this, if I want to create a plot with all of our columns, what I could do is I could copy this line, and then I could paste it, and then I would change the number to 3, and this number to 3, and then I could copy that line, and then change that number to 4. But because we're programming, we don't want to do that. We want the computer to change the number for us. And so this is a for loop where we're counting. We want to count over a number, so I think we should use a for loop. Does anyone remember how we do a for loop to count? The range for loop that we learned earlier. So that's what that sounds like. So we're going in, we're changing a number, we're going 1, we change the number to 2, then we change it to 3. We wanted to get all of the columns. So that sounds like a range for loop to me. So I am going to write a for loop to do that. I'm going to use range. Okay, so I'll do for call in range, and this is very similar to the for loop that we did before, I believe we had a variable called numcolumns. I'm going to check, so I just am inserting a cell in. I think we had a variable called numcolumns. Okay, we did. So I'm going to use that variable I already have. And I'm going to put that in my range function. And then if I want, I can print that call variable. So that's going to count for me 0, 1, 2, 3, 4. And then I'll want to create a, I want to add data to a figure. So actually, I forgot one thing before. I want to do plt.figure to create a figure. And then I want to use this for loop to count for me. And then I want to basically, for each column, I want to add a line to my graph. So I want to use this plot function for each column. So I'll do plt.plot, and then I put what I want to plot. I want to do data. I want to get all of the rows for the column, and then I want to put that variable call for the column number. And then I think I want to give it a label. So I'll do label equals, and then I'll do headers, COL. So we can see what this looks like. We can kind of check what we have. Oh, and one thing that we're going to see here, so this looks kind of weird. And if you think about it, you might think about what's happening here. That first column, or column index 0, is just a frame number, so it just counts to 10,000. So we probably don't want to plot that. And the way that we can choose not to plot that is actually this range function, we can put a starting number. So I'm going to tell it to start at 1 and go up to the number of columns. So I'm just going to modify my range loop a little bit. I'm going to change this so that there is a 1 in the front to tell it to start at 1. And now I've got all of my data on the same plot. So we probably can still think of ways to make this better. I want to add my labels. I want to add a legend. So when I think about that, I have to think, where should I add that? Should it be inside the for loop, or should it be outside of the for loop? So by inside of the for loop, that means that it happens every time it counts. I only have one graph here, so I think I want it to be outside of the for loop. So I'm going to come out of my for loop by pressing enter again, and then pressing the backspace button. And I am outside of my for loop because it's not indented. So Python tells where we are in for loops by where it's indented. And if I want to do something only once and not in the for loop, then I don't want to be indented under the for loop. So for a label, I only need to add the label once. And when I save the figure, I only need to save it once. So we can do plt.xlabel, simulation frame, plt.ylabel, distance, angstrom. And then when I'm done, oh, well, another thing I want to do is I want to actually add my legend. So I want to tell matplotlib that I need a legend. And then finally, I want to save the figure. And I'm going to save this as all samples.png. And I can go out and check. Now I'll have this figure saved. All right, we have a challenge for you. Challenge. So what I want you to do is to take this code and copy it into a cell for your challenge. So I want you to modify this code. So now, instead of one figure with all of the data on it, I want you to make 4 figures with 1 column of data each. So you have 1 figure with THR4 ATP, 1 figure with THR4 ASP, 1 figure with TYR6 ATP, and 1 figure with TYR6 ASP. And an extra bonus challenge is to figure out a way to save a different file for each column. Okay, let's talk about how we could do this. So we took this code that we already wrote, and what we want to do is, instead of having 1 figure with many different pieces of data on it, we want to have 4 figures, basically, each with each with their own line of data. And if we think about this, what we have to think about is what I put inside the for loop is what's going to happen every time, like every time we count. So I have to think about, what do I want to happen every time? And if we think about what we said we wanted to do, well, what I want to happen every time is I want to create a figure. I want to add my data. I want to add my labels. I want to add a legend every time. So that's what I'm going to start with. I'm going to leave off saving the figure at first because that's a little bit trickier. So I'm just going to comment that out because I'm not ready for it yet. But I said everything else I wanted to happen every time. So if I want it to happen every time in the for loop, I have to have it indented inside of the for loop. So I can just take these things and I can highlight them. And the way that I can put them all inside of the for loop is I can highlight it and press tab. And if I do that, it's going to tab everything over and to be inside of the for loop. So I could try executing this and seeing, how does this work? I'm like, that doesn't work. Well, you would think it would work. But then I realized, oh, what I'm missing. I've got to create the figure every time. This has to be inside of the for loop too. So I'm going to take this, I'm going to copy it, or I'm going to cut it actually. And then I'm going to go here, and that's the first thing that I want to happen. So I'm going to go to the very end of my line that says 4 and the colon, and then I'm going to press enter, and I'm going to put that as the very first thing that happens in my for loop. So let me try that out. Maybe that will work. And that looks much closer to me. Okay, so let's talk about this sort of bonus challenge, which was how can you save an image for each plot? And I'm just going to go over this because I think if you're doing research, this is going to be really useful for you so you can make a lot of plots at one time. But the trick here, and this is going to go back to some other concepts that we've learned about, but the trick here is that we basically want a variable in our file name because otherwise it's just going to overwrite the same file every time. And the file name has to be a string. And we know we've learned a way that we can put variables in strings. So I could do PLT. I'll do PLT.saveBig. And then I'm going to use my F string printing here so I can put a variable in my image name. So I'll do big F and then 2 quotes. And then in the quotes, maybe I'll put, you could put anything here that's that like changes. So you could just put call.png, like you could just put the number.png. I'm going to use my headers. So my variable is going to be headers and then square bracket COL, because remember that's going to be the name of the data. So I put that in those curly braces, and then I'll do .png. And this is really useful. Doing file names with variables is something that I find very useful when I'm like doing data analysis. So that's how you can do it. You can use your F string printing inside of this savefig command. Then maybe I want to make it high quality, but I'm not going to make it super high quality, so I'm going to make it 200. And then if I click back out here, I'm going to see that I have a different plot for each column. So I've got all of my column names here. I'm going to go back to here. One final thing is that actually I am kind of picky, and I noticed that here it goes to 20, and here it goes up to 11, and here it goes up to 18. I don't like that, and I want them all to be the same. So I'm going to add one more thing here when I'm creating my plot, and I'm going to say plt.ylim. And I'm going to use that to set what I want the y-axis limit to be. And I'm going to say 0. I'm just going to pick 0 and 20. I think that's how you do it. Yes. So I say for the y-axis, start at 0, go to 20. And then I can take a look, and they all have the same y-axis. So here is the challenge. The trick is that we want to do everything every time, so we have to put that all inside of the for loop. And then the second, which was the bonus, how can you save an image for each plot? The trick is to use our f-string printing and use a variable in the file name. And this is going to be really, really useful, this kind of thing, variable in the file name. So I want to cover one final thing on plotting, and then I'm going to turn it over to Dr. McDonald so she can tell us about your homework assignment to try for next time. But I'm going to just grab just this one where we had it all in the same plot. And I want to show you something about, well, actually, I'm just going to plot. I changed my mind. I just want one thing on this plot. So I'm just going to put in a 1 here. So I've got plt.figure, plt.plot, and I'm just going to plot the first column, column index 1. And I actually want to I'm going to set an X limit here. So we did ylim before. I'm going to set an xlim just to show you the first kind of 10 points here. So here you'll notice it only goes up to 10. Let's say I want to show you how you can have a little bit more customization for your plot. Like if you don't like this blue color, and you can do this with your other plots, we can change the color of this after we have label. Well, we actually need to take out label for this. So let's just take out label. We can, well, maybe we can leave the label in. If we put in quotes, I'm going to put R in quotes. And that tells matplotlib I want a red line. There are lots of other built-in ones. I think there's like magenta and blue, like I think B is for blue, so that's more blue. You can also have it basically be a scatter plot. So if I wanted to do like dots, I could use an O. If I wanted blue dots, I could do OB. And that will give me blue dots. But the shortcuts for these are just things you can look up in the matplotlib documentation. If I want a dashed line, I can do, if I want like a line between the dots, I can do -OB. So this is like dots connected by a line, blue dots connected by a line, for example. Or I could do --OB if I wanted a dotted line. So I don't expect you to kind of have memorized those or learned them. We have these lessons online, and they have like a key of different things. So we'll send that out to you. But if you do it enough, you'll remember some of them. But basically, what I wanted to show you is that matplotlib is very customizable. You can change the colors of all of your graphs, and you can change the type of lines and markers as well. Another fun one is this up caret does triangles. So that's just a kind of fun marker. Okay,